Today, I'm going to tell you the most important things you need to know about hydropower. And before I go into the next slides, just wanted to orient you to what a conventional hydropower plant might look like. So this is obviously the dam. You see the dam is wider at the bottom than at the top. It's having to hold back a lot of water. So the base tends to be really thick and get thinner as it goes to the top. It has less weight it's having to hold. You'll have something called a spillway. The spillway is where water can come over the top in case of the water in the reservoir that's being held back by this dam gets high. And so you'll see water released through spillways in times where there's been a lot of rain or something that's really filled up the reservoir quickly. And they can have the water come over the spillway. So it's kind of like a safety feature of our dams. And then what we're going to talk about today is not just the dams, but the hydropower itself. And so what you would see at a dam that has hydropower, many of them don't. We dam rivers for all sorts of reasons, like water or agriculture, or recreation, or flood control. But if it has hydropower, you'll see something like this. This is our powerhouse. Down here, that's where the electricity is being generated. And you'll see these pipes that are bringing the water from behind the dam to the powerhouse. These are called penstocks. And so that water is flowing through the penstocks, turning the turbine inside the powerhouse to create electricity. So what's the big deal with hydropower? Hydropower is actually our biggest renewable resource in terms of contribution to our power needs, our energy needs. So in electricity generation, which is what hydropower is really used for, it's just used for generating electricity. It's about 14% of the world's electricity mix. In some places, it's more important than others, though. So I wanted to give a sense of where hydropower is important in the world. You can see places like Central and South America. Hydroelectric is actually almost half of the energy mix in this yellow part in Central and South America. So in those countries, it is a very, very important resource. Some countries rely heavily on electricity. An area where it's growing a lot is in Asia, and we'll see some of that, especially in China. So China leads the world in hydropower and has seen a lot of growth and is continuing to grow in hydropower. Other top countries have kind of leveled off. You can see these are kind of the top 7 countries, including the United States. Most of the good sites for hydropower have already been taken advantage of in the United States. So we're not seeing a lot of growth in hydropower, but you can see the rest of the world, we are seeing some of that growth. It's not as big a growth as we see in our other renewables. So we're seeing about a 2% global growth in hydropower compared to our other resources like solar and wind. But we do see capacity additions happening, especially in places like China and Africa, where these might be very important resources for some of those countries. All right, so how does it work? So hydropower is from the energy of moving water. You've probably learned about the water cycle, right? So we have big bodies of water like the ocean, the sun's shining on it, the water evaporates, it moves over land, forms clouds, it's often pushed up mountains, it rains at higher or snows at higher elevations, and then we can take advantage of the potential energy difference between the high elevation where the water has accumulated in the high elevations and lower elevations with rivers and the flow of that water back to the ocean. So we're taking some of the energy out of that water that had been added to the water from the sun, making the evaporation and moving it over land. That's what we're using for hydropower. I want to make an important note about our water cycle and hydropower. So obviously hydro only works where there's water. And we're seeing changes in weather patterns. We're seeing more frequent and severe droughts. We're seeing shorter winters and early snowmelt. All of these things impact that water availability for hydropower because climate change is really contributing to these changes. So it is one of the vulnerabilities that hydropower has. Hydro has been used as an energy resource for a long time, not for electricity, but for other resources. So we've been using water wheels forever. That's both for milling or mechanical energy or moving boats, things like that. In the 1800s and early 1900s, we started using it for electricity, where we're getting more and more sophisticated about our turbines and how much energy they can extract from that moving water. And then they can spin and turn a generator to create electricity. And although hydro's share of the electricity mix has been going down, the capacity has been growing some. You saw that it's like 2% in the world. It's not really growing in the United States. So it's about the same amount of capacity for a long time in the United States. So its share of electricity mix has been declining. Let's talk about how it works in a little bit more detail. So I showed you the picture that's behind me of a dam. This is just kind of showing you the inside. So you've got the reservoir and you're taking advantage of the fact that the water is at a higher level behind the dam than it is at the river level. And so that potential energy difference, we can extract some of that energy as you're moving the water from the reservoir down to the river. And we do that through turbines that are spinning and spinning the generator to create electricity. Conventional hydropowers that have reservoirs, that's often what you think of with hydropower, and that storage area that's called pondage, that allows us to regulate when we are producing the electricity. So we can very easily kind of turn these hydropower systems up and down. They often have multiple turbines because they kind of have an efficiency at operating at a certain spinning rate. So you can turn on multiple turbines, or you can have less turbines, or you can have some of the water go around the powerhouse, depending on how much electricity you need at that moment. Another type of hydropower is something called run-of-river systems. So in run-of-river systems, we are still taking advantage of water being upstream, having higher potential energy than water downstream. This is more of an extreme case. You can even have it between waterfalls where we're not having a dam. And so in these systems, we have less control about how much electricity we can produce, but they have a lot less impact on the ecosystems because you're not flooding a river valley to make a reservoir. So in this system, you can see this one is just an example. You have an intake of water that's going actually underground here. It's coming out at this little spot down below the waterfall. So instead of the energy in the river being lost with all the churning and spray and everything that's happening over the waterfall, we're able to take it and put it through a powerhouse and make electricity with it and then send it downriver that way. So you can see how this would have a lot less impact on ecosystems. Some of the largest power plants in the world are hydropower. So here I'm just showing you a picture of the 20 largest power plants in the world, and you can see these blue ones, these are hydropower. So one of the interesting things about hydropower is we can make them extremely large, things like Three Gorges Dam, or we can make them really small. You can even have micro hydropower that works on your sink faucet and makes a little bit of electricity. So very scalable in terms of our hydropower facilities. And they're very critical for offering services to the grid. So don't worry, there's a lot going on this chart, but what I want you to take from it is over here, we have services that you want for the grid. This all helps with reliability or starting up the grid, keeping the electricity going, and different resources along the top. And what you can see is how green it is how useful it is for the grid. And hydro is one of those resources that is very useful in all these different categories on the grid. So lots of grids want to have at least some hydro because it's best at providing some of these critical services to the grid. One of those is something called black start. If your grid goes down and you need to restart it, hydro is perfect for that because a lot of these resources like coal and nuclear, natural gas, they need electricity to start producing electricity. And hydro doesn't. You can literally send somebody out and they can open a valve and start water flowing and they can start producing electricity. So hydro is really important for bringing grids that have come offline back online. So when you have a blackout, having hydro on your system is really important for getting the grid started back up. Other thing hydro can do is it's super flexible. So if you have that reservoir, you have something conventional like the one behind me, and you have water in it, it can really rapidly go up and down and help with following supply and demand on the grid and helping with integration of other renewables. We also have systems that are called pumped hydro. And so pumped hydro is different. This is not an energy resource like the dam behind me. This is a battery. This is where we can store energy or store electricity from the grid. And so typically with pumped hydro, you have an upper reservoir and a lower reservoir. This can be large, like giant lakes. It can be small, like tanks. But basically what you're doing is when you have excess electricity, like when there's excess solar in the middle of the day, you're able to pump water using those same turbines from the lower reservoir to the upper reservoir. And then in the evening, when the sun has gone down and you need electricity production, you can put it back through those turbines, create electricity, and put in the lower reservoir. We have a lot of pumped hydro systems on our grid. That's what's been providing some of the storage ability on our grid, but it tends to be a pretty land intensive resource. And so in terms of the energy density you're getting per land, it can be pretty small depending on how deep these reservoirs are. For a long time, pumped hydro was really the only thing that was providing storage on our grids. But as battery costs have come down, batteries offer a lot of flexibility. There's a lot easier to site than pumped hydro because you don't need particular geography. You can make them small, medium, or large. You can fit them in at certain points of the grid where that storage is really valuable. Batteries have really been growing, and we expect as things go forward, batteries will likely take over as grid scale energy storage. But one of my hydro friends would probably say, yeah, it's not really fair. Pumped hydro is not the only storage that hydro's providing. Having a big reservoir like this is also a type of energy storage. So let's talk about an advantage of hydropower and then some of the impacts of hydropower. So one of the advantages one of the reasons we're excited about hydropower, I've been using it for a long time, is the low greenhouse gas emissions. And so on average, hydropower is very low greenhouse gases, even when you're looking from a life cycle per the amount of energy that's being produced. You can see it kind of falls with some of our other renewable resources, much, much lower than our fossil fuels. So the diamonds are the median, but you can see there's this big range for hydropower. And that's because a lot of times when you make a hydropower reservoir for these big conventional ones, you're flooding vegetation. And that vegetation, once it's flooded with water, will decompose and release methane, which is a potent greenhouse gas. Other impacts of hydropower, I think a lot of these are pretty obvious, but you're fragmenting up the river habitats, you're changing how the water flows, blocking fish migration, flooding valleys, which can destroy farmland, ecosystems, communities, cultural sites, things like that. And you can see this is just one example of how it really changed not only the river characteristics, but where spawning could occur for a particular species. So we see a lot of impacts from dams. Remember that dams are put in place for a lot of reasons, not just hydropower. And often hydropower is kind of like the last thought. And so a lot of times it isn't as dispatchable as you might think because the primary use of that reservoir is for other purposes. Like I said, whether it's flood control or recreation or agriculture. Hydropower in itself also has other environmental impacts. Obviously, fish is a pretty obvious one, where if the fish are often going through the turbine and coming out through the turbine, this can kill or injure fish. It can also disorient them. We've seen places where there's hydropower where things like bears will sit right downstream of the dam because the fish that are coming out of that are all disoriented and they're much easier to catch for predators. And of course, it disrupts the natural river flow patterns when you're doing this. This is just an example where the river flow is following demand on this electricity grid. And you can imagine that this isn't the natural flow. Finally, let's talk about what's going to happen future-wise. Other renewable resources are more cost-effective than hydropower, but in places where hydropower is available, there's still a lot of interest in it, particularly in places we talked about like Africa and China. But the overall average shows a downward trend in new additions. All right, if you want to know more, we have an excellent professor, Dr. Freiberg, who is a world-renowned leader in not just hydropower, but in all sorts of dams. So you can go watch that lecture on our website. And of course, I encourage you to join our Energy Spotlight.